Now we are going to start with the valency. Now what is the valency? First of all, you should know what are the valence electrons, because before we take up, we should be familiar with valence electron and valence shell. As we did in the previous lecture, that if I take an example of magnesium whose mass number is 24 and atomic number is 12. So the number of proton is 12, number of electron is 12, number of neutron which is taken up by by subtracting the mass number from the atomic number, we get the neutrons are also 12. I am writing the electronic configuration. You all know now how to write it now. Yeah. So you know the valence shell. Till this you all know. Now what is the valence electron? The electron which is present in the last shell is called as valence electron. So its valence shell is M and its valence electron is 2. Right? Similarly, one more example for you to make it easy. So if I take an example of carbon, mass number 12, atomic number 6. By looking at proton 6, electron 6. So by looking at electron, I am writing the electronic configuration, shell. This is the valence shell and valence electron is 4. Now what is the main role of valence electron? As I told you, valency has the main role and it directly depends upon the valence electron. So now the valency is indicated by the valence electron. Now how it depends on the valence electron? See, either it is equal to number of valence electron or it is equal to 8 minus valence electron. Now from where does this 8 comes? You must be thinking that from where does this 8 come? Why not 9? Why not 10? Why only 8? So you should know that there is a rule, that is the octet rule. What is it? See, in nature every substance or every particle or whatever you say needs to attain stability, right? So in case of atom or an element I am talking about, or an atom you can talk, because element is definitely made up of atom only. So in this, the atom, to attain stability, the atom must fulfill this rule, that is octet rule. Now what is it? It says that the atom should get the maximum of 8 electrons in its outermost shell. As we know, the first shell can accommodate maximum of 2 electrons, I told you according to Bohr-Bury rule, and second as 8, third as 8, again you know that. So these are the minimum electrons that an electron should accommodate. Maximum 2 can be there, second shell maximum 8, third also maximum 8. Actually from third onward it obeys some anomalous exceptional properties you will be doing in +1, because at this moment we are not familiar with the blocks, we are not familiar with the, you can say the way of writing the electronic configuration. So we will be doing it in the next year, in the next standard, but for now, for the sake of now, you just remember that when the 2 electrons are filled in the first shell, start filling the second shell. When it is filled with the 8 electrons, start filling the 8 electrons. Now what is the reason? We will be doing in the next standard, right? I will try to make it easy if you can get it. So according to octet rule, what does it state? It states that any element need to attain the noble gas configuration. Noble gas configuration means the stable configuration. Now what does this mean by stable configuration? Means having the 8 electron in outermost shell means to attain stable configuration, means to attain noble configuration, means to complete an octet. So any element need to have 8 electron in its outermost shell. So this is how, when he wants to combine, for this, for the sake of the stability, it is combining with some other atoms, so that either it is fulfilling its octet by losing any electrons, either it is fulfilling its octet by gaining electrons, or it is doing it by sharing, but somehow it needs stability, and for this it is losing, gaining or sharing electrons in order to attain 8 electrons in its outermost shell. So from this octet rule, oct means 8, so from this octet rule this 8 is taken. So the next step is how we determine the valency of any element. So for example, I am taking an example of carbon again, C12, we have proton 6, electron 6, neutron 6, and this thing, mass number 12, electronic configuration 2, 4. So valence shell is L, valence electron is 4. So valency is equal to either this valence electron or 8 minus the valence electron. So because it is 4, it can either lose or gain electron. So for your simplicity, we will be doing it later. I am just taking some other example to make you more clear, then you yourself can answer it very easily. So let me take an example of lithium. I have told you atomic number 3 means electron 3. I am not writing proton and neutron, you all know how to write now. So electron to 1. So valence electron is 1. So 1 valence electron means either it lose 1 electron. So by losing 1 electron, it will acquire only 1 shell, and we know 1 shell is full when it contains 2 electrons. So either it can attain the stability by losing this 1, right? Or it can gain 7, either lose 1 or gain 7. By gaining 7, it will become 2, 8. So which is simpler? What do you think? Which is simpler? Gaining the 7 electrons or losing 1 electrons? Losing 1 electron. The smaller the number, the easier it is going to be. So that means it can lose 1 electron, and by losing 1 electron it will acquire only 1 shell, that is K shell, and K shell attains stability when it contains maximum of 2 electrons, we already did, right? So the valency of it is 1. How? That means it will lose 1 electron or it will gain 7. It will lose 1, na? So by losing, whenever any element lose electron, its valency comes out to be a positive 1. See, to make it more easy, I'll tell you, we'll take one more example. See, as it has this in 2 electron, we'll be taking some octet 1 example. So let it take sodium. We know atomic number 11, configuration 211, 281, valence electron 1. So that means to attain stability, either it gains 7 or it lose 7. As I have told you, smaller the number, easier is the task. So that means it is going to lose 1 electron, right? So after losing, this shell is lost, we are left with 2, 8. So is it stable? Tell me, is it stable? Yeah, because it contains 1 shell K, it has 2 electrons, L shell as L, second shell as L, it contains 8 electrons, and we know that 8 electrons are the maximum electron that L shell can have. So it is stable now. So now coming to the valency, how you will write the valency? Now you know the valence electron, you know that it is going to lose electron. So what comes out to be valency? See, earlier the number of proton was 11 and number of electron was again 11. Now to attain stability, it has lost 1 electron. Now proton as such 11 and electron has become 10 now. So we know that atom is electrically neutral, so earlier proton and electron number was same, but now after losing, the proton and electron number doesn't remain as such, doesn't remain same. Now electron is 1 unit less than the number of protons. So that means which charge is more in atom? Which charge is more, proton or electron? Because neutron has no contribution, because as we know it is neutral, it has no charge. So we have to consider only proton and electron, positive and negative charge. So out of it, which is bigger? Which is maximum? Proton. By how many units? 1 unit. So its valency is going to be plus 1. Plus indicate positive, the positive charge particle is more. By how many units? 1. So its valency is going to be 1. Similarly, if I take an example of nitrogen, atomic number 7, configuration 25. Now it can attain stability by losing 5 or gaining 3. So it will gain 3, because I told you smaller the number, easier is the task. So it will gain 3. So earlier the proton was 7, electron was 7. Now proton remain unaffected because protons are never lost or gained. It only happens at electronic level. Now electron, it has gained 3 electrons, so it becomes 10. Earlier configuration was 2, 5, now configuration is 2, 8, right? So what it has done? It has gained electrons, so that means electrons are increased, means negative charge is increased. By how many units? 7 to 10, 3 units, so minus 3. Its valency is minus 3. And so you can do it. This I have explained you because so that you can know that how actually it happens, why +1 or -1. Or I can tell you one more hit and trial method which can be used by just looking at the valence electron. So by looking at the valence electron, you can easily say that its valency is +1, +2. You don't need to write the proton, electron, neutron configuration like that. You can just randomly write the valency like that. See the hit and trial method. If valence electron equals to 1, 2 or 3, then the valency is +1, +2 or +3 because it is definitely going to lose the electron. So just look at the valence electron. If valence electron is 1, +1, just randomly write +1. If 2, +2, 3, +3. Logic you know, we already did in the complete explanation by elaborating the topic. So just by looking at the valence electron, hit and trial method is this. And if you see that the valence electron is 4, 5, 6 or 7, then what you will do? Minus it with 8 because we know octet means 8. So just from the 4, just minus it from 4 and the answer is going to be negative because it will be gaining electrons. So -4, -3, -2 and -1. So simply looking at the valence electron by hit and trial method, you can write just the valency randomly. See, repeating again, 1, 2, 3, +1, +2, +3, 4, 5, 6, 7, just minus it from 8, -3, -2, -1. And see, the 4. Now 4 can be +4, can be -4. So just write +-4. In some compounds it is showing the plus valency and in some it is showing the minus. So for 4 write +-4, any of it can be. And if it is 8, then tell me, if it is 8 then that means octet is complete. It don't need, it has already got the stability, the noble as configuration. It doesn't have to lose or gain electrons. So its valency is 0. And which elements whose octet are complete are already complete, you don't need to lose or gain electrons or shuffle any kind of electrons. Those elements are called as noble gases. So noble gases are helium, neon, argon, krypton, xenon. All of these gases has complete octet with 0 valency because their octet are complete. So we one more thing I would like to tell you, that in case of for all the elements it is the octet rule which is to be followed. But for the hydrogen it is 1 electron. So what will happen? It will lose 1 electron. After losing it will not left with any of the electron, or it will gain 1 electron. By gaining, its first shell will become 2, that is it is going to be filled. So its valency can be minus plus both ways. When it is combining with metals, we take it as -1, but otherwise the maximum it is taken as 2, it gains 1 electron. So in case of hydrogen, instead of octet rule, this rule is called as duplet rule. This is just for this case of hydrogen or helium. Helium already has a duplet because it has got 2 electrons. So when we will write it in the configuration, it is going to be 2, right? And for the hydrogen it has got 1, it will take 1 and then it will achieve the duplet. So otherwise for all elements it is octet, but for hydrogen and helium it is an exceptional case, this octet rule get converted into the duplet. That means tendency to have 2 electrons in the outer shell. As they contain only 1 shell, so 2 electrons are required in the first shell to attain stability. So that is why they show the duplet rule. Otherwise for all atoms they need to have 8 electrons in their outermost shell, and for that they are shuffling the electrons, losing, gaining or sharing. So this is the octet rule. This is how you can calculate the valency. I am repeating it again in a short note. Valency depend upon valence electron. Valence electron is present in the valence shell. So if valence electron is 1, 2, 3, definitely they will lose the electron, and after losing the positive charge will be more, +1, +2, +3. And if it is the 4, 5, 6, 4 can be plus minus, and 5 onward it is 8 minus these, and the valency comes out to be minus because negative charge is going to exceed, and for 8 noble gases 0. So whenever now you anybody tell you to write the valency, so how you are going to do that? Just write the symbol of the element. Right, if you know the valency, then it's okay, just write directly 2 positive. If you don't know, concentrate on the atomic number, write the number of electron, configuration, look at the valence electron 2, just this should flash in your mind 2, that means it is going to be +2. So simply write +2 on its as a superscript. This is how the valency is written, and it plays an important role, because if you will not know the valency, you are not going to make the chemical formulas or the molecular formulas. You have to cram it. So the better way is to go into the deep, just know how they are coming, what are the valencies, so that you can easily make the chemical formula and do the chemical reaction